Today we will be discussing the insertion sort. For that we have taken this array with 5 elements 1, 4, 5, 2 and 3, right? What happens in case of the insertion sort is that we consider the array index or the element at array index 1 and we go on comparing it with the elements at indices right up to 0. That means this 4 would be compared with this 1 because that is the only element till index 0 is reached, right? Similarly, the element at this position at the index 2 would be compared with these two elements or right up to the index of 0, right? Similarly, for 2 would be comparing it with the elements or the places with indices of 2, 1 and 0, and in the meantime would be sorting each position. That means if we would consider that the element at the first position is already sorted, then 4 would remain here or it would move to this place depending upon whether it is smaller or greater than this element. So if we take the example of this array, in that case we will have no shuffling of elements or values across the indices of 1 and 0 because 4 is greater than 1. So smaller element is sticking to its 0th position. So it must be said here that I am talking in the context of ascending sort, right? So similarly, when we consider 5 with respect to 4 and 1, I guess it should retain the position as it is greater than both 4 and 1. So let us without wasting consider the code and try to hand simulate how it basically works. So this would be your code, right? So I have started here from index 1 and I will have to go right up to the index of n or less than n. So n in this case represents the total number of elements in this array, right? So before moving to the next lines of code, let us do some hand simulation first. And what are the values, different values that we'd be needing during the course of time? Would be needing k. K is storing the array ith element. So since we are starting with the i's value of 1, so this would be arr 1, right? Arr 1 is 4 here, if you can see. So that has been stored in k, right? Right, so basically what that means is that we are checking whether the 4 should stick to its position or remain its position or it should trickle downwards, right? And that comparison process would be taken care of by this while loop and this instruction, as we'll be shortly discussing it, right? So as you can see here that the j loop or the j iterates from the values or whatever the values it takes starting from I minus 1 right up to the greater than or equal to 0. That means this 0 is the last index it should be compared with, or this is the j's latest value or the value beyond which it should not go, right? So let us now move to some kind of simulation so that it helps you understand what actually happens during the comparison processes, right? So for that I have written here what are the values I would be taking, j would be taking, and arr j and k. In the meantime, we'll be seeing these with reference to this code, right? So to start with, if I is 1, that is written here since we have initialized I with 1, so I would start with 1. In that case, j would be what? I minus 1, that is 0. That is what I have written here. What would be arr j? Arr j would be arr 0, right? That is 1, since arr 0 means this element 1. So what is k? K is 4, right? Because k is equal to arr I is 1. So arr 1 means 4. That has been stored in k. Now go to this while loop. So while loop says this code should execute while j is greater than or equal to 0. Is it so currently? Is j greater than or equal to 0? Yes. And but at the same time arr j, what is arr j? Arr j is 1. It should be greater than k. Is 1 greater than 4? No. So this while loop would terminate. it won't be executed in even once, right? Rather control should move to this position, right? What does that say? ARR j plus 1. Now remember j is 0, ARR 0 plus 1, that is ARR 1. That means this position should store what? K. What is in K? 4. So that basically means no change took place as far as the position of 4 is concerned. So up to this point of time, or up to this place, the array is sorted. Why? Because we have till now considered the elements 1 and 4 only, and they are in perfect shape as far as ascending sort is concerned, right? So having done this, control should now move to this for loop, which would take, by virtue of this I plus plus, the next iteration. What would be I now? I would be now 2, right? J would start from 1 less value, because j is equal to I minus 1, so it would be 1. ARR j would be 4, right? What is j's value? 1. So ARR 1 means 4, and K would be what? K is ARR 2. So K is ARR 2, which is 5, right? ARR 2, which is 5. So next would be comparing. So j is greater than or equal to 0, of course, but is ARR j, that means 4, greater than 5? Is 4 greater than 5? No, right? So no change would take place. So control would go to this place, ARR j plus 1, which is ARR 2, would have the value of K, which is 5. So that is why it did in the previous iteration also in case of 4 that no change took place. Here also no change would take place. So ideally up to this point we have the sorted array, which you can see 1, 4 and 5 are already sorted. So the control would go here, and I would now be 3. Right? Of course, j would start from 2, 1 less value, then I, right? So what is ARR j? ARR j is 5. And what is K? K is now 2. K is now 2. Right? K is now 2. Now you can see the change. Is 5 greater than 2? Yes. So it is true. So 5 should come here. This 5 has been moved to this place by virtue of this statement, and j has been decremented, right? What happened to this 5? It would also remain, because you have simply copied this 5 to this position, right? Now some of us would ask that what happened to this 2, right? If we copied this 5, sorry, if we copied this 5 to this place, what happened to 2, right? But don't worry, because that 2 has been already saved in K, right? So we'll be hopefully finding a place for that 2. So for the timing, let us move to the next iteration when I would still be 1, rather 3, and the control, since the while loop condition turned out to be true last time around, so control would stay within the while loop, but this time with the value of j as 1. Why 1? Because we did j minus minus, right? Or we simply decremented. So ARR j now would be 4, right? And K, again it is still 2, right? So I would be comparing 4 and 2. Is 4 greater than 2? Yes, this time also some changes are expected. So 4 would come here, right? 4 would come, so that 5 is gone. Now 4 has come in its place, right? Now j minus minus would turn this j into value of 0. So would be considering what element now? ARR j, which is ARR 0, which is 1, and it would be compared now with 2, because K is still 2. Is 1 greater than 2? No. So the control would come out of this while loop. Control would now go to this place. What is the next instruction to be executed? ARR j plus 1. So it would be ARR 0 plus 1. That means 1. ARR 1 is equal to K. So ARR 1 is this position. So at that position we will be storing what? K's value, which is 2. So you have sorted this. So you have basically brought this 2 from this place to this place. So if you can see now, up to this place, since I is 3, up to this place we have sorted this array. So you have the elements 1, 2, 4 and 5, which are perfectly sorted, right? So overall this array is not sorted fully, as you can see we have not done anything to this 3. So that would be done when I would be 4. That means we are now considering this cell, and we will be seeing the most appropriate position for this 3 to go, right? That is this place, I guess. So 5 should go here, 4 should go here, and 3 should come here. So let us do it by virtue of this simulation. So j would be 3 and arrj would be 5, and arri or k, it would be 3, right? Is 5 greater than 3? Yes, of course. So it would take 3's place, right? Then I remaining as 4. 2 would now be, j would now be 2, and arrj would be 4, and 4 would be compared with what? 3. Is 4 greater than 3? Yes, it is, right? So now we have reached the position where I is equal to 4 and j would be decremented to a value of 1. So arrj, which is 2 now, right? So would be compared with this 3, the current value of k. So it should bring out this change, right?